Algebra 2, Unit 1 Study Guide. Please use this video as a key to check your already completed study guide. Problem 1. We're going to graph a linear equation, so we're looking at it in y equals mx plus b form. M is our slope. We're going down 5 over 1, and we're starting at 1, which is our y-axis, our y-intercept. Problem 2. Write an equation in slope-intercept form of a line that passes through these 2 points. So first of all, we're going to find our slope. We do y2 minus y1 on top, x2 minus x1 on bottom, and make sure you simplify that all the way. So I got 1/3. Next, we're going to find our b value. So using y equals mx plus b, we're going to plug in an x and a y value, so pick your favorite point, plug those in for x and y, and solve for b. Last, we need to write our final answer as an equation, so we get y equals 1/3 x minus 5. Problem 3 has a few parts. First of all, let's note that we are picking between 2 rental venues. Venue A charges a flat rate of $600 and $15 per guest. Venue B charges can be seen in the table. So part A asks us to write an equation for modeling venue B, which is the table. So first, we need to pick 2 of our favorite points from the table. You can pick any 2. I picked these. And we're going to find our slope, y2 minus y1 over x2 minus x1. Next, we're going to solve for our y-intercept b. So we're going to pick one of the points from the table using for our x and our y. We're going to plug those into our equation along with our 20 for slope, and we're going to solve for b. Make sure in the end you write your final answer as an equation. Part B. At how many guests do the 2 venues cost the same? In order to answer this question, we're going to have to set our 2 equations equal. So let's start by writing an equation for venue A. We have a $15 per guest rate and a $600 flat rate. So 15 is going to be our slope and 600 is our y-intercept. Next, we're going to set the 2 equations equal to each other and solve for x. Our final answer here is going to be 40 guests. So when each venue reaches 40 guests, they cost the same amount. Part C asks to predict how much each venue will cost if they have 220 guests. So we're just plugging in 220 for x. So first of all, venue B, if we plug in 220, we get $4,440. And for venue A, when we plug in 220, we get $3,900. For problems 4 and 5, we're going to be graphing the systems in order to find the solution. Problem 4, both of the equations are already in y equals mx plus b form, so we can just go ahead and graph them. Start with your y-intercept, your b, and then do your slope. And in the end, we find our answer to be the point 1, 2. Always make sure to write your final answer as a point. For problem number 5, neither of our equations are currently in y equals mx plus b form, so we first need to solve for y. In the first equation, we're just going to move the 3x over by subtracting, and then we can go ahead and graph that. The next equation, we have to divide everything by 4. Make sure you remember that there's a 1 in front of that x. In the end, our final answer is the point 0, 1. Problem 6 says to solve any way, so I could use either substitution or elimination here. I personally prefer elimination, so that's what I'm going to do. I'm going to eliminate my y's, so I'm going to make them negative 3y and positive 3y. Add down, solve for x, and I get 1. Then take my x value and plug it back into either of the original equations, and I get y equals 1. Again, make sure that you write your final answer as a point to receive full credit. Problem number 7, this time again I would definitely use elimination. On problem 6 we could have used substitution since there was a y that just had a coefficient of 1, but for 7 I would use elimination even if I liked substitution more. So I'm going to eliminate my y's. I'm going to multiply the top by a -3 so that it makes a -6y. Add down and solve for x. We get x equals 6, and then plug 6 back into either of the two equations for x and solve for y. On problem 8, again, I'm going to use elimination. I think it would be pretty easy to eliminate my x values, so I'm going to multiply the bottom equation by a -3 in order to make it a positive 3x. Once I do that, I notice something here. Both my x's and my y's are going to eliminate. So when I add down, I get 0 equals -5. That's a false statement. Therefore, the answer is no solution. If I had gotten a true statement like 0 equals 0, then my answer would have been infinite solutions. On problem 9, I'm going to switch it up here and do substitution. Substitution works well for this problem because we have a variable that has a coefficient of 1. So you see that top y that has a coefficient of 1. So first I'm going to solve for that y, and then I'm going to take what y equals and plug it into the other equation for y. Eventually I will solve for x and get 7, and then plug that into either of your equations for x and solve for y, we get 6. So my final answer is the point 7, 6. Alright, now time for the 3-variable system. So first of all, you need to group together equations 1 and 2 and 2 and 3 on the lines provided. Next, we're going to look at which variable to eliminate. So we could eliminate our x's, our y's, or our z's. Personally, I think the y's look easiest. On the right side, I just have a -y, so it'd be really easy to make a positive 3y. So I'm going to eliminate out my y's. Creating opposites, multiply by 3 and 2 on the top and the bottom. Be really careful here in your multiplication. It's so easy to make a mistake. Remember, make sure you eliminate the same variable on the right side. So make sure we still eliminate our y value. We're going to need these two equations copied down to the next box now. Alright, in this next box, we're going to take the two equations from above, and we're going to use either elimination or substitution. It was already set up with opposites, so we solve for z and get 2, plug that back in, solve for x, and we get -1. Now you can go ahead and write those on your final answer line there at the bottom. In our final box, we're going to take one of the 3 original equations from the start of the problem. I picked the first one. And we're going to plug in -1 for x and 2 for z and solve for y. Again, just be very careful with all the multiplication, adding, and subtracting going on here. Our final answer is the point -1, 5, 2.